Let's talk about counting atoms and formulas. This is a critical concept to be able to do. So when we get to balancing equations, also when we get to counting up, determining molar masses. So let's look at a few compounds and determine the number of atoms in each of these. So let's look at something like barium nitrate. And so we've got one barium, and the parenthesis, subscript 2, tells us we have 2 of everything that's inside the parenthesis. So we've got 2 nitrogens. For oxygens, we've got 3 times 2, or we've got 6 of those in all. And so that's the number of each type of atom in barium nitrate. Sometimes you'll see organic compounds written out in a condensed formula, structural formula like this. This happens to be acetic acid. And so we see there are 2 carbons. If you count up all the hydrogens, there's a CH3, there's 3, and then an H at the end, there's 4. And then there are 2 oxygens. So that's the number of each type of atom in acetic acid. Some compounds come as hydrates, where there are orders of hydration that are included in the crystal structure of the compound. So this compound is called strontium nitrate tetrahydrate. So let's count up the number of each type of atom. We've got 1 strontium, and then like the nitrate from the barium nitrate up above, we've got 2 times 1, we've got 2 of those. And then for the oxygens, we've got 3 times 2 from the nitrate, but we also have 4 from the orders of hydrations. So in all, there are 10 oxygens in strontium nitrate tetrahydrate. And then if we look at the hydrogens, we've got 4 H2Os, so 4 times 2, that'll give us 8. So that's the number of each type of atom in sodium nitrate tetrahydrate. And one more just for grins. This is ammonium nitride, where the nitrogen's got a -3 charge associated with that nitride. And the ammonium, each one of those had +1, and that's where it gets to be electrically neutral. So from nitrogen, in the parenthesis, we got 3 times 1 plus the 1 outside. There are 4 nitrogens. And for the hydrogen, we got 4 times 3, or 12 hydrogens. So this is how we go about counting atoms and formulas.